Great, thank you. So today I'm going to tell you about GenomicAI, which is essentially artificial intelligence that can help us feed the world. So I'd like to start with this question, and that is, what do burger patties, jet fuel, and plastic bags have in common? And the answer to that is that they are all targets for sustainability through synthetic biology, which is the act of reprogramming biological organisms at the molecular level to have them do things that they've never done before. This is for our benefit mostly. And this industry is currently valued at $9.5 billion globally. And today I'm going to focus in on food, because we can all survive without aircraft and plastic bags, but we cannot live without eating. Currently, our population is almost 8 billion and growing, and it's slated to reach 11 billion people almost in the year 2100. And this has really fueled the drive to develop better ways of making food. So that's given rise to the field of food biotechnology. And the four central goals of food biotechnology and food synthetic biology are to make food safer, more nutritious, tastier, and more sustainable. So the name of the game is to, make food more accessible and use less land and water resources to achieve that purpose. And there are already a few companies that are working on it. Just to name a few, you've probably heard of Benson Hill, Impossible Foods, Beyond Meat, Aqua Bounty, Air Protein, and Motif Foodworks. And so they're essentially trying to do two simple things: make cheap and tasty ingredients. So the holy grail of making food cheap and tasty is to get the smell, flavor, and texture right. And so we already enjoy a diverse variety of smells and textures and flavors from natural foods. And there's an ongoing battle to make new next-gen foods taste like the food that we're used to. So where does GenomicAI come in here? Well, GenomicAI helps us to get the recipe right, which is most important. So GenomicAI is a bioinformatics software. And when I compare it with state-of-the-art, I'd like to use this eggs analogy. With state-of-the-art bioinformatics software, you can get something like hard-boiled eggs with some salt and pepper, very simple ingredients. Whereas GenomicAI can suggest different recipes, different ingredients that you can use to make these beautiful deviled eggs. So how does GenomicAI work? So we start here on the left with the raw genome sequence of a new organism that is of interest. There is typically going to be a little bit of functional data available. For example, volatile organic compound profiles, which influence the smell of the food that comes out of the organism. And so our AI has an understanding of biological function, and we have pretty rich and rapidly expanding genomics databases here at LANL, and we're also curating data that comes into public databases from around the world. And using this AI, we are able to develop understandings of flavor profiles, and therefore we can provide quantitations on the flavor components of a food, as well as genetic control points by which these flavor components can be controlled. And these suggestions become targets for experimentation. And scientists that do the experiments, or robots that do the experiments from the lab, produce results which can then be fed back into our system to get feedback and improve the AI understanding of getting the recipe right, essentially. So there are a few companies that are in general doing similar things to us, and compared to them, our compute speeds for our AI calculations are not the best. But where we really capitalize is on the utilization of reams and reams of genomic data, which other databases are not so good at doing, the software are not so good at doing. And our other USP is our explorative nature of the AI, which does not suffer from any kind of knowledge-based confirmation biases. And so we are able to make suggestions for genetic improvement that typically these other softwares won't. And they're high quality suggestions. And because they are high quality suggestions, they reduce the number of attempts needed in terms of experimentation to achieve a desired target in terms of a flavor, texture, and smell profile. And that leads to reduced costs. So we are in the very early stages of development, and we actually seek to work with data-driven synthetic biology companies who have access not only to large genomic databases, but also have the capabilities to do experiments at very large scales, which is essential to the development of our AI. So we want to work with companies like Ginkgo, Inscripta, BotaBio, BGI, and Veritas, for example. And once we've established that our AI is robust, we seek to then go out to public databases and benchmark our annotations, for example, the piece of information we are able to synthesize from genomic data, and then compare to what is available in publicly available databases like NCBI, Joint Genome Institute, PFAN, KEGG, and the European Nucleotide Archive. And so here is our technology roadmap. Again, as I mentioned, we're in early validation, and then we're going to do a lot of this work internally. And then in the second year is when we hope to reach out to the synthetic biology companies and develop collaborations and then robustify our AI, go out to the public databases in year 3. And finally, once we have a pretty robust and solid proven system, we've established our credibility, we will reach out to the actual target, the ultimate target, our food tech companies. And so we will provide our GenomicAI as a service, standalone, as well as value-added services on the backends of the companies like Ginkgo Bioworks and Inscripta. So let me tell you a little bit about our market segmentation. The global enzymes market within the field of synthetic biology is valued at almost $11 billion. And the food enzymes market constitutes a third of that, approximately at $2.9 billion. And the bioinformatics effort that goes into development of food enzymes is roughly 20%. So we estimate that our market size is actually $150 million. And our CAGR growth rates are estimated to be around 5 to 7%, so very decent. And this is without the presence of GenomicAI. No one knows about GenomicAI yet. And we think that by introducing GenomicAI, we may be able to boost these growth rates even further. So finally, a little bit about myself. I'm a bioinformatician here at Los Alamos, and I have 14 years of programming experience, 10 of which have been specifically in bioinformatics and protein engineering. Over the last 3 years, I've been working on data science related problems in biology. And one of my projects has actually led to the development of GenomicAI. So I'm currently looking for microbial synthetic biology industry partners, as well as genomic data centers, public and private, and food tech industry partners. So if you are or know of anyone who fits these descriptions, please feel free to get in touch with me. Here are my contact details. And I thank you for your attention, and we'll take any questions.
Thank you, Shounak. So I'll open it up to our panel for any questions. Our friendly sharks.
This is Mike. How you doing? I'm a little bit unclear on where your IP is. I mean, if you looked at all the different data sources and technology you need to kind of feed into the AI, where is your IP and all that? I wasn't exactly sure.
Yes, our intellectual property is in the curated database. So there's a lot of data out there, and it can be good and bad data. So we are doing a lot of work to curate that data. And part of that curation process, as well as the curated data that comes out of our pipeline, is the IP. And of course, the AI code base.
Can you explain to me exactly what the value you would be adding to a customer like Beyond Meat? Is it just better ingredients, better source? Like what? It's not exactly clear to me what value the customers would be receiving from this type of product.
Of course, thank you for your question. So, so the main value we bring is novel insights into genomic control points. So if, for example, they are trying to develop a genetic engineering project and have reached a plateau in terms of this flavor profile and are looking for new avenues in terms of genetic engineering to improve their flavor texture profiles, our software can find these new leads for them.
So it adds value in terms of customer insights, essentially.
Yes, it adds valuable insights. Yes.
Okay.
So you talked about the market size being around 150 million. That's pretty small, I'd say, for most startups. Are you envisioning a larger market after you prove that segment out? Just walk us through that a little bit. And then also just curious, is that 150 million estimate you provided, is that actually for very similar work being performed now with other competitors? How do you kind of come to that number, 150 million?
Yes, so it's from our initial estimate of inputs into bioinformatics projects, and it's based on an assumption of the number of design, build, test, and learn cycles that the synthetic biology companies are doing. And from what I've not had much of input into this cost from the customer discovery that I've done so far. So I will this number is probably going to change, but not by much. But it's still a work in progress, I'd say. And to answer your first question about the outlook for the industry, yes, so that is the at least our belief that we should be able to boost the growth rate and help realize food flavor, texture, and smell goals, or that one wouldn't even dream of at this time. And then by taking existing processes, we can figure out for the same target, say one wants to make a Beyond Meat or Impossible Food soy burger, meat, if I may call it that. So we can help figure out more cost-effective production techniques, exploring new hosts for expressing the kinds of proteins and carbohydrates that are required to get that Impossible Meat or Beyond Meat, Impossible Food or Beyond Meat kind of flavor and texture profiles. And so it will work in two ways: reducing cost of existing processes, as well as make possible open our eyes to the possibility of making, for example, growing mushrooms synthetically, getting a mushroom-like flavor, portobello mushroom-like flavor from an entirely synthetic process.
Okay, well, thank you so much, Dr. Banerjee. Thank you, Sharks. I think we can move on to the next presentation. We're running a little bit behind, so I'll introduce our next presenter. Our next presenter with Breezy Robotics, Dr. Matthew Ennis, the Chief Strategy Officer with Build with Robots.